Hello friends, welcome to my YouTube channel. In this video, we have to discuss about a new long question, that is gametogenesis. What are the phases, types of gametogenesis? Okay, let's read the questions carefully. What do you mean by gametogenesis? Briefly describe the stage of spermatogenesis and oogenesis. The stages of spermatogenesis and oogenesis. Differentiate between spermatogenesis and oogenesis. So there is a question asked to our mind, that is, what is gametogenesis? Simply the formation of gamete is known as gametogenesis, or the process by which haploid gametes are formed from the diploid germ cell of gonad, that is called gametogenesis. What is the definition? The process of formation of haploid gametes, that is n number of chromosome, from the diploid germ cell in the gonad, that is 2n number of chromosome, for sexual reproduction is known as gametogenesis. We know that gametes are required for sexual reproduction. So, this is the definition. Now, the types of gametogenesis. What are the types? Gametogenesis in human is of two types. That is spermatogenesis and oogenesis. In spermatogenesis, sperm is formed, and in oogenesis, ovum will be formed. Let's see what is spermatogenesis. Similarly, like gametogenesis, the process by which sperms are formed from the testis, haploid sperms are formed from the diploid germ cell of testis. The process by which sperms are formed, haploid sperms are formed, or n number of the sperm having n number of chromosome is formed from the diploid germ cell of the testis is known as spermatogenesis. It occurs in male gonad, that is testis. Male gonad is testis. The entire process of spermatogenesis can be divided into two phases. What are the two phases? Formation of spermatid is phase 1 and spermiogenesis is phase 2. So let's see what is formation of spermatid and what are the phases of formation of spermatid and what is spermiogenesis. Formation of spermatid. At sexual maturity, the primordial germ cell of testis in male give rise to spermatid through the following step. So, in the formation of spermatid stage, at sexual maturity, after the maturity, the germ cell of the testis, primordial germ cell of the testis in male, testis is present in male, as that way primordial germ cell of testis in male gives rise to spermatid through the following step. What are the following steps? Let's see. First is phase of multiplication, phase of growth, and next phase of maturation. Phase of maturation. So, what is phase of multiplication? In phase of multiplication, the primordial germ cells of testis multiply repeatedly again and again. The primordial germ cell of testis multiply repeatedly by mitotic division. The division is mitotic, are known as spermatogonia. From primordial germ cell by mitotic division. Primary spermatogonia will be formed. By repeated mitotic division, spermatogonia are formed having diploid number of chromosomes. Here the chromosome is diploid. Also the primordial germ cell will be diploid. The primordial germ cell is diploid. After the division, after the mitotic division, the spermatogonia is formed and that spermatogonia is diploid. Then growth phase. What is growth phase? In the growth phase, the spermatogonia which is formed from the multiplication phase do not divide. That does not divide. And it increases in size. It increases in size by accumulating nutrition. What are the nutrition? That get the nutrition from the Sertoli cells and from the supporting cells, or that supporting cell is also called as Sertoli cell. Sertoli cell. That from that Sertoli cell, the spermatogonia get nutrient and enter to the growth phase. And the enlargement of spermatogonia are now called primary spermatocyte. After the growth phase, the spermatogonia enlarge and which is known as primary spermatocyte. After that, the primary spermatocyte enter into the maturation phase. So, the primary spermatocyte which is diploid undergoes fast meiotic division. In multiplication phase, the division is mitotic. But in maturation phase, the primary spermatocyte fast undergoes the fast meiotic division to form haploid number of chromosome. So, after the fast maturation division, that is reduction division. The fast maturation division is also known as reduction division. In reduction division, the chromosome number reduced to half. Reduction. Okay. The primary spermatocyte which is diploid undergoes fast meiotic division, that is reduction division, to form haploid secondary spermatocyte. Primary spermatocyte which is diploid, that formed secondary spermatocyte which is haploid. Okay. The second, after the fast meiotic division, the secondary spermatocyte will be formed. After that, the second mitotic division gives rise to 4 haploid spermatids. Okay. We get the spermatid. The formation of spermatid phase is now completed. So, the phase of formation of spermatid is completed. We have to go formation of spermiogenesis. What is spermiogenesis? Now, we have to find the definition, we have to know about spermatogenesis. What is spermatogenesis? In the process of spermatogenesis, in the process of spermatogenesis, the spermatid are transported into sperm. That is known as spermatogenesis. The formation of sperm from the spermatid is known as spermatogenesis. What are the changes takes place in spermatogenesis? The changes which takes place in spermatogenesis are the large spherical nucleus. The spermatid contain large spherical nucleus of spermatid becomes elongated but reduced in size. The size of spermatid is big, but after the spermatogenesis process, the spermatid converted into sperm by losing its weight, and the spherical nucleus became elongated. The Golgi body is condensed into a cap-like structure called acrosome. The Golgi body of the spermatid condensed into a cap-like structure called acrosome in front of the nucleus. If this is a sperm, then this is the nucleus and this is acrosome, a cap-like structure, that is acrosome. The acrosome is formed from the Golgi body. Okay. Now, the nucleus and acrosome together form the head of the developing sperm. The nucleus, this is the nucleus, this is acrosome. These two are together form the head of the sperm. This is the head, this is neck, this is middle piece, and this is tail. This is a sperm. Okay. While the cytoplasm with mitochondria are centrioles, there are two centrioles present in the neck, or we can write it is present in the middle piece also. And mitochondria are present inside the middle piece. Mitochondria and centrioles move towards from the middle piece behind the head. Okay. Now, two centrioles of middle piece develop axial filament with form long vibratal tail. The axial filament form the long vibratal tail. The spermatid, which is a typical cell, is transferred into a mitotic sperm divisible into head, middle piece, and tail. Okay. The spermatid, which is typical cell, rounded and big in size, that converted into very small size and transferred into motile sperm, which motile means which is movable, which can transfer from one to another place. That is movable capacity, which has its movement capacity, that is called motile sperm, divisible into head, middle piece, and tail. Let's see the figure of spermatogenesis. If you understand the figure of spermatogenesis and oogenesis, you can easily write the total long question. First, the phase of multiplication, phase of growth, and phase of maturation. Okay. In phase of multiplication, first we take primordial germ cell. Which is diploid that undergoes multiplication phase and form spermatogonia. Two spermatogonia which undergoes multiplication phase, that is mitotic division. Mitotic division. Mitotic. Okay. After the mitotic division, we get two spermatogonia. Then we enter this one spermatogonia. One of them undergoes the growth phase. In this growth phase, the spermatogonia achieve nutrient and get big in size. That is big in size, and which is known as primary spermatocyte. The size of the spermatogonia increase in the growth phase, and that became the primary spermatocyte that undergoes the fast maturation division. That is, fast maturation division is reduction division. Reduced. Okay. Which undergoes fast maturation division, the diploid number of chromosome reduced into haploid. Can you understand? The diploid number of chromosome reduced into haploid. Now, that haploid number of chromosome, which is haploid things, are known as secondary spermatocyte. Which is known as secondary spermatocyte. Okay, that secondary spermatocyte again undergoes second maturation division, which is equational division. It is known as equational division. Okay, to form four number of spermatid. In second maturation division, the secondary spermatocyte undergoes the second maturation division, which is equational division, to form spermatid. Now spermatid is formed. That spermatid undergoes spermatogenesis to form sperm. Can you understand? Okay. Next, hormonal control of spermatogenesis. What are the hormones which control the spermatogenesis? Gonadotropin releasing hormone. Gonadotropin releasing hormone secreted by hypothalamus which is secreted by hypothalamus. Gonadotropin releasing hormone which is secreted by hypothalamus stimulates the secretion of luteinizing hormone, that is LH. Stimulates the secretion of luteinizing hormone, that is LH, and follicle stimulating hormone, that is FSH. The first hormone is gonadotropin hormone, which is secreted by hypothalamus, and that stimulates the secretion of luteinizing hormone, that is LH, and follicular stimulating hormone, that is FSH. These two hormones are controlled by gonadotropin hormone. FSH is secreted from pituitary gland and gonadotropin hormone is secreted by hypothalamus. Remember it is, these are very important. Okay. LH act on the Leydig cell of testis. Luteinizing hormone act on the Leydig cell of the testis, stimulating the secretion of androgen. Androgen means testosterone hormone. In male, testosterone hormone is released. Testosterone, okay. Androgen means testosterone, which in turn stimulates the process of spermatogenesis. Okay, that androgens stimulates the process of spermatogenesis, and FSH acts on Sertoli cells, which helps in the process of spermatogenesis. These are all over the spermatogenesis. Next, significance of spermatogenesis. What are the significance of spermatogenesis? During During spermatogenesis, one spermatogonium produces 4 haploid sperms. From one spermatogonium, okay, we get 4 haploid sperm. Due to haploid sperm, after fertilization, the zygote become diploid. Due to haploid sperm, after the fertilization, the zygote became diploid, which maintains the constant chromosome number in the species. These are the significance of spermatogenesis. Next, oogenesis. What is oogenesis? This is very simple. You can say oogenesis is the process by which ovum are produced from haploid ovum are produced from the diploid germ cell of ovary. Okay, oogenesis is the development of female sex cells, that is called ova or eggs. Female sex cells, Newton. Female sex cells called ova or eggs in the female gonad of ovary. Female gonad is ovary. It is divisible in the following phases. It has also 3 phases, that is phase of multiplication or multiplication phase, phase of growth, that is growth phase, and phase of maturation, that is maturation phase. What are they? Phase of multiplication. In the phase of multiplication, the primary germ cell of the ovary with diploid number of chromosomes. The primary germ cell of the ovary with diploid number of chromosomes, having 2 number of chromosomes, divided several times mitotically. We know in multiplication phase, the primary germ cell undergoes mitotic division. So, it undergoes mitotic division, repeated mitotic division to produce a large number of oogonia cells. Can you understand? These cells are called oogonia cells. That is spermatogonia, this is oogonia. Now the oogonia undergoes growth phase. Okay. So what is the growth phase? And when the oogonia undergoes growth phase, what are the ability formed by it? What are the different formed in this phase? So let's see. In growth phase, the oogonium increase in size. How it increases in size? We know in growth phase, it contains nutrients from other cell. It gets nutrients from the other cell and increases its size. So the oogonium increase in size in both nuclear and cytoplasmic portions, and it is called primary oocyte. The oogonia increase its size in both nuclear and cytoplasmic portion, and this is called primary oocyte. Okay, next the maturation division. Wait, the growth phase of oogenesis is longer than that of the spermatogenesis. This is not described in this, so I want to describe the total. The phase of oogenesis is longer than that of the spermatogenesis, and in this growth phase of oogenesis, both nuclear cytoplasmic materials takes place. Their production of more amount of nuclear sacs, synthesis of all types of RNA. All types of RNA are formed in the growth phase, and enlargement of nucleolus. The nucleolus of the ova get enlarged, and increase in number of mitochondria. The number of mitochondria increased, number of ribosome increased, number of endoplasmic reticulum, Golgi body, etc. are increased. In this page, synthesis of yolk YOLK, that is yolk. Synthesis of yolk, that is reserve food. This yolk is reserve food. Takes place inside the egg, which is known as, this synthesis of yolk is called vitellogenesis. Vitellogenesis. Okay, this is not described. And synthesis of giant cell is also takes place in this phase rather than human being. This is not formed in human being. Synthesis of giant cell is formed other mammals. Due to this, primary oocyte becomes large in size and go to the phase of maturation, that is maturation phase. So what is the phase of maturation? Let's see. The primary oocyte undergoes two successive division by meiosis. First division is reduction and second division is equational. So first reductional division, the first division, that is meiosis 1, which is reductional division, and two unequal daughter cells are produced. Unequal, not equal. Two unequal daughter cells are produced. In first mitotic division, the diploid oogonia undergoes oogonia or oocyte, that is oocyte undergoes the first maturational division, that is meiosis 1, which is reductional division, to form two unequal, that is one larger, one smaller, two unequal cells called, one is secondary oocyte and which is large in size. The larger size is called secondary oocyte and the smaller size is called fast polar body. The formation of fast polar body is formed here. Two unequal daughter cells are produced, one larger, one smaller. The larger is called secondary oocyte and the smaller size is called fast polar body. Can you understand? Next, the secondary oocyte and the fast polar body then again undergo the secondary maturation division. After the fast maturation division, secondary oocyte and fast polar body are formed. These two undergoes again the second maturation division, which is meiosis 2, and that is also equational division. The secondary oocyte form a large passive functional ovum. The ovum is functional and second polar body. The secondary oocyte formed second polar body and the fast polar body again divided to two polar body. They are formed two polar body. So three number of polar bodies are formed. Thus at the end of oogenesis, only one functional ovum is formed. The ovum is functional and only one ovum is formed from one oogonia. And there are three polar bodies are formed. Okay. Next, see the image. Phase, multiplication, maturation, and multiplication, growth and maturation. In multiplication phase, which contains 46, human body contains 46 number of chromosomes, 2 into 23, that is 2n. Okay, undergoes oogonium, undergoes fast mitotic division to form oogonia. These oogonia are formed. Multiplication takes place of ovaries of female fetus, unborn female baby. Okay. After that, primary oocyte is formed in growth phase. In growth phase, the oogonia get larger in size to form primary oocyte. The primary oocyte again undergoes meiosis 1. that is reductional division. Meiosis 1, that is reductional division to form secondary oocyte. One is larger, one is smaller. The smaller one is called polar body and the larger one is called secondary oocyte. Okay. Again these two undergoes the second maturation division. In the first maturation division, the diploid chromosome turns into haploid, and these two undergoes again the second maturation division, that is equational division, meiosis 2 division, to form the first polar body formed two polar body, and the secondary oocyte formed one functional ovum, one large functional ovum, and one polar body. So we got one oocyte, and here if the sperm is connected by the ovum, then we got the zygote. Can you understand? Let's next, hormonal control of oogenesis. What are the hormonal control of oogenesis? Anterior lobe of pituitary secrete LH and FSH hormone. Okay, anterior lobe of pituitary secrete LH and FSH hormone under the influence of a gonadotropin hormone secreted from the hypothalamus. Gonadotropin hormone is secreted both male and female from the hypothalamus, which stimulates the secretion of luteinizing hormone and follicular stimulating hormone, that is FSH and LH. FSH induced growth of Graafian follicle. The FSH stimulates the growth of Graafian follicle and initiate meiosis 1 in primary oocyte as the form of secondary oocyte. Next, FSH also stimulates ovary to synthesis estrogen. FSH, the function of FSH is that it also synthesizes the estrogen hormone, and LH induces the rupture of mature Graafian follicle and release to secondary oocyte. These are the function of FSH and LH. These are very important. Significance of oogenesis. One oogonium produces one haploid gamete or ovum and three polar bodies. One oogonium produces one haploid gamete or ovum and three polar bodies. We get polar bodies are haploid cells which are destroyed. They contain little cytoplasm. Polar bodies are small in size, so they contain little cytoplasm. Most of the cytoplasm goes to the ovum and used as a nutrient for early embryo. Most of the cytoplasm undergoes the ovum and used to nutrient for the early embryo. They are meant to remove haploid chromosomes. Okay, this is the conclusion. And the difference between oogenesis and spermatogenesis, you can easily determine the difference between them. So I cannot describe it. I can't describe it. If you want to, I will describe it. The difference between spermatogenesis and oogenesis. Please comment. Then I will make another video, that is the difference between spermatogenesis and oogenesis. This difference contains 3 marks, so you can this video will be very long, so I'll not describe. I'll describe it in the another video. Thanks for watching.